All right, so state the end behavior zeros and multiplicity of the polynomial. Now for the end behavior, we need to look at two things. We need to look at our leading term to determine, is my degree odd or even? Is it positive or negative? And so in this instance, it's positive and even. So my end behavior is going to start going up, stuff is going to happen in the middle, and it's going to end going up. Now to turn that into a mathematical statement, x is going in two directions. So as x goes to negative infinity, my y goes to positive infinity. As my x goes to positive infinity, my y also goes to positive infinity. Now, to find the zeros, we need to factor it. Okay, so there's an x squared in common, so I'm going to factor out the x squared. And I could factor that further. So my zeros are going to be 0, -1, and +1. You have to set each factor equal to 0 and solve. Now the multiplicity is how many you have. So I have 2 zeros. So I have 2 zeros that are 0. I have 1 here, and I have 1 here. And so I guess you can include that, but all of that is the answer. So for this one, I need to know the leading term, so to find the end behavior. So remember, to find the leading term, you just multiply the leading term of all the factors. So x squared, because I have 2 of them, and x to the 3rd. So that's going to be x to the 5th. Now that means my end behavior will look something like that. So when x goes to negative infinity, my y value is also going down. When x goes to positive infinity, my y value is going up. So as x goes to negative infinity, my y goes down. As x goes to positive infinity, my y goes up. Now my zeros, you set each factor equal to 0. So if I set x minus 3 equal to 0 and solve, you get 3. X plus 2 equal to 0 and solve, you get -2. Now how many do I have? So that's your multiplicity. So multiplicity 2, and I have 3 of them here. So to find the end behavior, we need to find the leading term, so multiply all the factors, the leading terms of the factors, so x times x squared times x, so that's going to be x to the 4th. So my end behavior is positive and even, so it's going to be just like number 1. So it's both going to go up like that, and then, you know, as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. Now my zeros, I have 3 of them, so I have to set each one equal to 0. So x equals 0 is 0, x minus 3 equals 0, you're going to get 3. X plus 1 equals 0, you get -1. And so now how many do I have? That's your multiplicity. I only have 1 of x equals 0s. I have 2 of the x minus 3's equals 0, and I have 1 of the x plus 1 equals 0. For this one here, I have x squared times x times x times x. So that's x to the 5th. So my end behavior is going to be similar to here. So like number 2. And so my zeros, if I set each factor equal to 0, so I get 0, I get 3, I get -1, I get +5. And my multiplicity, how many of them do I have? 2, 1, 1, and 1. So for this one, my end behavior, it's 4 times t squared times t, so that's 4t to the third. So that's positive and then odd. So because it's positive and odd, it's going to be very similar to like number 2, and it's going to be very similar to number 4 because that's also positive and odd. So number 2 and number 4, just to save time. Now my zeros. Now, if I say 4 equals 0, that doesn't make any sense. So it's not a 0. But that t minus 2, I can solve for that. So I get t equals 2. And then I get -1/2. Subtract 1/2 on both sides. So then my multiplicity, how many do I have? I have 2 and I have 1. Okay, so solving these, I get log base 5. And this is going to be 2x plus 1 times x plus 2 equals 1. Base 5 to both sides. Now it's quadratic, so I want to multiply this out. So 2x times 2x is 2x squared plus 4x plus x plus 2. So 2x squared plus 5x minus 5 on both sides, so that's -3. A times c. A times c, you get -6. Factors of -6 that are going to add to 5. So that's going to be, well, we have -2 and -3. That's not negative, right? So it's going to have to be +6 and -1. So then 2x squared minus x plus 6x minus 3 equals 0. Factor by grouping. So x plus 3, 2x minus 1. So you're going to get x equals -3 and +1/2. So now plugging back in. If I plug in -3, I'm going to get a negative inside my log, so I have to reject it. If I plug in the 1/2, I don't, so 1/2 is going to be my answer. For a problem like this one, you could actually probably just combine ln's together. So I can add the ln x to both sides. So you're going to get 4 ln x, and then if I add 2 to the other side equals 3. Divide both sides by 4. And then you can take base e to both sides. So x equals e to the 3/4. If you plug it back in, you're going to get positive values inside, so it shouldn't be any issue. For number 8, I need to combine these together. Now this is a minus, so that means this is going to go in the denominator. So log base 169 of 3x plus 7 over 5x minus 9. That equals 1/2. Base 169 to both sides. So 3x plus 7 over 5x minus 9. That equals 13. Multiply both sides by 5x minus 9. So I get 3x plus 7 equals 13 times 5x minus 9. But you can go through and solve the rest from there, because that's linear. The next one, solve ln of 3 minus y. Minus ln y equals 2x plus ln 5. Okay, so this x here is just there to throw you off. We're solving for y. It just means I got to get y by itself. Y equals something. It's okay that that x is there. Just remember it's a different term, so things won't combine together. So I can't add the 2x and this ln 5 together. So just don't let that throw you off. But I can combine these together. And so that's effectively what we're going to have to do first. So I'm going to get ln I just want to make sure. You know what? And I want to bring this ln over. I want to get all my ln's on one side. So I get ln of 3 minus y minus ln of y minus ln of 5 equals 2x. So now, combining these, the 3 minus y goes on top because it's positive. The log is positive. And then the y times the 5 go on the bottom because it's negative. And that's going to equal 2x. I can take base e to both sides to get rid of the ln. So now I get 3 minus y over 5y equals e to the 2x. I can multiply both sides by 5y. So 3 minus y equals 5y e to the 2x. I have y's on both sides, but I can't add anything together. So the strategy is to group them. So I want to add the y to the other side. So I can factor out the y. Then I can divide by the 5e to the 2x plus 1. For number 10, solving this exponential equation, you need to make the bases the same. So this is 2 to the 4x, and I can make this the same. Now, if you can't, remember you got to take log both sides and solve it that way. But now that the bases are the same, you can assume the exponents equal each other, and so, whoops, divide both sides by 4. Little dyslexic. And now I can take log to both sides because I can't turn a 3 into a 29. So then I get log 3 to the x minus 1 equals log 29. I can move that to the front. Divide both sides by the log 3. Add the 1.